Are you a developer without a computer science degree? Maybe you're self-taught, maybe you went to a boot camp, or maybe you watched an online course like this one. Do you ever wonder what you might have missed out on that computer science graduates didn't? Or maybe you're trying to prepare for the dreaded coding interview. This course can help. This course covers all the important computer science topics you might have missed, whether you're looking to ace the programming interview or simply become a better developer. My name is Colt. I'm an engineer and an in-person bootcamp instructor. And this course is directly rooted in my experience teaching hundreds of new developers all the skills I need to crack tough coding interviews and land six-figure jobs in the really competitive landscape of the Bay Area. So unlike other courses out there, this course doesn't just show you a bunch of problems and then tell you the tricks to solving those specific problems. It's more about building a complete computer science foundation so that you can solve any problem, whether you've seen it in a course before or not. We talk about how to assess your own code, how to compare algorithms as far as time and space complexity is concerned. The course gives you a whole new language to discuss your code with. All right, on to the details. So we start out covering important concepts like big O notation and recursion before learning the 5-step approach to solving any problem. It's not a scam, I promise. After discussing programming patterns and interview strategies, we cover dozens of different algorithms, including searching algorithms like binary search, and 6 different sorting algorithms, including the infamous merge sort, quick sort, and even radix sort. Then we implement over 10 data structures from scratch, including stacks and queues, singly and doubly linked lists, binary search trees, heaps, priority queues, hash tables, and even graphs. It's crazy. Like my other courses, this course is interactive the entire way through. So I introduce some new concept, we talk about a challenge or a problem, maybe give you a couple of hints, and then I give you time to try it on your own. Then we meet back up and talk about a couple of solutions. And we just repeat that about 100 or so times. And all you need to get started is a basic understanding of JavaScript syntax. It's an unfortunate reality that coding interviews can be really intimidating, more so than regular interviews, which already are very intimidating. And on top of that, many companies insist on asking questions that are geared towards computer science graduates. So this course can help you navigate those obstacles, and even if you have no intention of interviewing or ever working as a developer, this course can help just make you a better engineer and a better problem solver. So sign up today and see what all this computer science nonsense is all about.
At the beginning of every single section, there is a text lecture, an article called Prerequisites, and that explains, at a minimum, the sections you need to have finished before you start the new section. And so let's just begin. The very first section, or technically the second one, but the first technical section is called Big O notation. Really important stuff. We come back to it in every single section from basically there until the end of the course. It's a way of describing or talking about the performance, the efficiency of code. So we use that all the time. So definitely don't skip that. Then we move on to a really quick section called Analyzing Performance of Arrays and Objects. Nice and short. We take what we just learned about Big O notation and apply it to some built-in data structures we work with all the time. So that's really quick. Next, we shift over to talking about interviews, algorithms, challenges. Basically, what do you do when you're confronted with a tough problem and you don't know how to solve it? Whether that's in an interview and you're at a whiteboard and you're panicking, or it's at home, you're working on a side project, or at work, how do you approach a difficult problem? And then the second sort of, what goes in tandem with that, these are 2 sections, problem-solving approach, problem-solving patterns. When we talk about patterns, we actually get into specific sort of archetypes for your code. They have different names, things like divide and conquer, sliding window, frequency counter patterns. These are all different patterns we describe. There's a lot of challenges. This first section that comes before is more about sort of setting up a framework for you to think and approach a problem. This is about concrete patterns. Then we move on to recursion. So recursion, a really important topic. Definitely don't skip this if you're not familiar with recursion. It comes up later on in many of our algorithms. There's also 2 challenge sections, sort of intermediate recursion problems and then tougher recursion problems that follow this section. Then we move on to searching algorithms, fun one. We talk about things like binary search here, if you've heard about that. Then we move to sorting algorithms. So I think we have 6 sorting algorithms at least, and these are kind of fun. If you've never worked with sorting algorithms, you've never heard about them, they have some odd names. We start with bubble sort, which is often considered the easiest or one of the easiest. We move to selection sort and then insertion sort. And those 3 form a little group, sort of the intermediate or elementary sorting algorithms. Then we move on to everyone's favorite merge sort. I like merge sort. A lot of people don't. Then we get to quick sort. So these all involve recursion. They involve big O notation. So it's very important that you pay attention to the prerequisite little text lectures at the beginning of every section to explain what you need. And then we finish up with radix sort, a pretty rare sort, very fast in a special situation, and not very often taught. Not in my experience, I've never really seen it taught. It's a fun one though, I actually really liked it. So from there, we get to sort of the second section of the course. Up until this point, it's been about sort of stepping stones, recursion, big O notation, problem-solving approaches, lots of algorithms, searching, sorting algorithms. Then we transition to data structures. So from this slide until the end of the course, there's a ton of different data structures we talk about. And this intro section compares them all. It tries to answer the question, what's the best data structure? And the answer is that there isn't one, but we talk about where they excel or certain structures excel. We also talk about ES 2015 class syntax, if you're not familiar with how you can approximate an object-oriented class using JavaScript. We talk about that in this section. Then, I'm just going to run through these quickly. Singly linked lists, then we cover doubly linked lists. So if you've never heard of these data structures, very understandable, but we spend a lot of time talking about them. Then we move on to two more, stacks and queues, very commonly used structures. Then we go to binary search trees. Really, it's trees in general, and then we specifically hone in on binary search trees. Then we have a section devoted to tree traversal. So if you've ever heard the term breadth first search, depth first search, post order, pre-order, in order, depth first traversal, that's the kind of stuff we cover here. Important, somewhat intimidating, and again, it calls on things like big O notation and recursion. It builds on linked lists. So a lot of this is interconnected, but you could also jump here and just look at the prerequisites and figure out what you need to learn. So then we go to binary heaps, which is it's very related to trees, but very special case. We talk about building something called a priority queue. This is a fun section, in my opinion. Then we go to hash tables. I also like this section. Hash tables, we talk about a very particular data structure that what we're doing here is sort of understanding how JavaScript objects work, how they're implemented behind the scenes. How would you implement a key value pair data structure? And we talk about hashing algorithms. I think it's a fun one. Then we go to graphs. Something that a lot of people are intimidated by. We talk about how you would model GPS, global positioning. Oh God, my cat. Hey, you can't interrupt me like that. What is it? GPS mapping, figure out how to find, basically how would you represent a map and traffic data and all these different variables so that you could create a GPS application or something like that. We also talk about storing social network data and one-way relationships, two-way relationships. We explore a lot of stuff around graphs, networks, routing. We talk about graph traversal, which, well, I won't get into too much. Same thing, breadth first, depth first, if you've heard of that. And then one of my favorite parts of the course, and one of the more complicated things we talk about, is called Dijkstra's algorithm. And this has to do with finding the shortest path between two nodes on a graph, two vertices. If that means nothing to you, well, this course is still definitely for you. You're not expected to understand what that is. But if we go back to the idea of GPS, say you want to get from point A to point B, from New York to Los Angeles. What's the fastest way to do that on the roads? If we have a complete map of all the roads, and let's ignore traffic data, just distances, what's the best way to calculate that? I mean, there's so many possibilities. So we learn an algorithm to do that, and we do basically an approximation of the same thing. It's this very famous mathematician and computer scientist, Dijkstra, came up with it, and that's what we talk about here. And this is sort of a pinnacle of the course because it relies on big O notation, recursion, it relies on heaps, binary heaps, priority queues, stacks. A lot of things that we talked about earlier in the course come back in this last section. Oh, graphs, I forgot to mention graphs. So that's where we finish up. Really just to revisit this, there's a division right here, Intro to Data Structures, where everything else is focused on individual data structures from there on out. And before that, there's some really important stuff, sorting algorithms, searching algorithms. But no matter what, I recommend you start with big O notation, don't skip the recursion sections, and then from there, totally up to you. Just pay attention to the prerequisite lectures. You absolutely can go in order. I mean, it's designed in an order. It's not just arbitrary. But if you don't want to, sit through all of doubly linked lists, you could skip it as long as you did singly linked lists. Anyway, I'll see you in the course. Goodbye. I don't know how to end this. Bye.